Unit 4, Section 3. Isosceles and equilateral triangles. So we have two different types of special triangles. One is an isosceles and one is an equilateral. We have some others as well, but for this section we're going to discuss these two. And here are some visuals. The isosceles has, you can see legs, a base angle, and a vertex angle. So let's learn a little more about that with our vocabulary. So an isosceles triangle is a triangle with two sides of equal length. All right? The two sides of equal length are called the legs. So the two equal sides of an isosceles triangle are called the legs. So if we look at the visual across, this is a leg and that's a leg. All right? We call this the base because it's what it's standing on. And we have a vertex angle. So next vocabulary word is the vertex angle. That's the angle that is between the two legs. So you see the two legs and then that's the angle. It's also known as an apex angle. All right? So then there can be a line of symmetry, which would be the segment that's drawn from the apex angle to the base, and it creates two equal triangles. Because the sides are equal, the angles are equal, so therefore when you split it down the middle, you create two equal triangles. You can imagine that will help us when we're solving some problems. And then an equilateral triangle is even simpler. It basically has all three sides and all three angles equal. And because we have to take a triangle, and a triangle has 180 degrees total, that means that each of these angles will be 60 degrees. All right, so let's look at some examples. We have example 1, find the value of x. Well, we can see that there are two equal angles here based on the symbols that are shown. So that means that this is an isosceles triangle. So that means that 2x minus 6 is equal to 8. Very simple two-step equation. 2x is 14, x is 7. So we found the value of x. All right? Example 2, we see that this is an equilateral triangle. See how each of the sides are all equal? That's not isosceles, then that's equilateral. So then we know that 2 must be equal to 60 degrees. So if it says angle 2 is 67 plus x, well, what would x be to make that 60? X would have to be negative 7. It's unusual to have you can't have an angle that's negative. You don't really have a side that's negative, but you could definitely have an x that's negative because once you plug that back in, you come up with an actual positive value for the sides or the angles. So let's look at 3, example 3. Once again, I see two angles that are equal, which means I know that my sides are equal. So that means I know that x is 10. That's obviously one of your simpler problems. And example 4 is not too complex either. We know this is an equilateral triangle, so we know that x is equal to 60 because we know all of the angles in an equilateral triangle are equal to 60. Hopefully this one will feel a little bit easy. Isosceles and equilateral make a lot of sense. You've probably seen and heard of them before, and all we're doing now is using their qualities to solve some problems. So I think this one you might be able to breeze through pretty fast. Go ahead and tackle that exit ticket. Good luck.